Sure. Welcome back, everyone. We're going to get started now. Our next speaker is Kyle. He's from the Pennsylvania Broadband Development Authority. He's a planning specialist there. He leads the mapping and data efforts for the authority. Previously, Kyle has worked in the public and private sectors to support various disciplines in planning, land use, transportation, community resiliency, and hazard mitigation. He knows a lot of information. This will be a good session. We'll do questions at the end.
All right. Hopefully my mic is on and everyone can hear me. So good morning, everyone. My name is Kyle Snyder. As Pat introduced, the real trick today, besides pronouncing this title, is finishing everything in 20 minutes. So I will do my best to stay on topic and on time. So today's talk is the pivotal processing power of Python and GeoParquets. So hope to talk a little bit more about integrating GeoPandas and Pandas into your GIS or data analysis workflows, and how you can leverage that using Parquet files to kind of enhance your workflow. So today's topic, trying to mix things up, but we're going to talk about a little bit about Python's use in GIS, or how you can integrate it a little bit better. The spatial Python ecosystem, as it's kind of a broader universe than most of us know. What is Pandas and GeoPandas that I'm here to talk about, and what is a GeoParquet file, and how can you leverage that? So as many of you may or may not know, Python is well integrated in the GIS ecosystem. It just depends on kind of what route you want to go. Python really integrates nicely for geoprocessing in ArcMap, ArcPro, and even QGIS as well. So on the flip side of that, when you go more into kind of the open source packaging, you can see that there's a lot of specific packages, and we'll touch into that a little bit later. But you'll see that there's a broader ecosystem of how we can use Python to analyze data that is inherently spatial. And on the right-hand side is just kind of an XKCD, comic about managing Python ecosystems, or Python environments, just because if you have Python 2.7 and Python 3.6, they all kind of clash and it becomes a mess eventually. So the spatial Python ecosystem that I talked about, this is more kind of in the open source world, but a lot of the geoprocessing we do is really based on a few different things. So GDAL, which is the Geospatial Data Abstraction Library, GEOS, and Proj are kind of the three big ones. So Proj is the .proj files you see in your shapefile as one of the sidecars. So that's the projection management for all the different spatial projections we have. GDAL is a lot of tooling and file interconnectivity utilities, and GEOS is spatial engines, I believe. So and we'll also see here that GeoPandas is kind of another core that's really at the center of a lot of different Python packages that we'll talk about. And just to name a few, so on the left-hand side, GeoPandas, PySol, and Shapely are three big kind of packages now if you want to get into kind of open source data processing with Python. So GeoPandas is literally built on the Pandas package, which is for tabular data analysis. PySol is more for kind of geometric manipulation, and then Shapely is similar to PySol, but there's kind of a lot of nuance. You can also do raster analysis with Python as well. So there's Xarray, Rasterio, and GDAL. So you can do projecting raster images. You can analyze like RGB, or even kind of get more into other specifics of raster data. So what is Pandas? I've talked about it quite a bit so far. So it's a library originally created to work with tabular data. And as a lot of you know, Python, or excuse me, not Python. Spatial data is inherently tabular data with geometries that are represented in space. So kind of the basis of Pandas is working with data frames, or kind of attribute tables that we would commonly think of in a desktop GIS. So this allows for manipulation of data, and honestly, you can think of Pandas as field calculator on steroids. Like, you can do so much and more with it, and it's pretty fast and intuitive once you know a little bit of basic Python. So GeoPandas is an extension of the Pandas package, but it allows for this geometry field here. So if many of you have worked in like SQL databases, you'll know that there's a geometry column. So what this does is it interacts with GDAL, Geos, and Proj, the packages I mentioned earlier, and kind of integrates that all nicely with working with tabular data. So not only can you kind of field calculate columns to do, addition, math, or string editing. You can also manipulate like doing spatial joins, clips, your standard geoprocessing in Python. So fundamentally, the usage is the same as using Pandas, which there's a pretty rich ecosystem for and a lot of good documentation and case studies, but it allows you to really utilize this geometry column through all of this. So GeoParquet files, and I'll kind of flip back to the previous slide here, but a Parquet file it's a file type. So like there's GeoPackages, shapefiles, geodatabases. Parquets is another type. So if we go back here, if this was a CSV file or a shapefile, when you go to access this, so you want to do a query to select all counties that equal Allegheny, for example, it would have to scan row by row to determine if that attribute in that column matches, which isn't necessarily the most efficient way of doing things, whereas a Parquet file is column-based. So it searches and compresses by columns, which we'll get into in a little bit. But what this means is that your read-write times are incredibly faster than standard files. So a lot of people say a shapefile is faster than geodatabase if you're just doing some simple processing. I would argue a Parquet is even faster than that. And we can kind of get into that a little bit. So a GeoParquet is similar to the relationship between Pandas and GeoPandas. The only difference is that it supports the geometry column and allows for the storage of spatial data. So at the bottom of the screen, I pulled a data set to kind of show the comparison, but so Microsoft and Bing did that machine learning data set of building footprints for the whole country. And it comes as a GeoJSON file in its stock format, and that's about 1.2 gigabytes. And doing nothing else but converting it to a GeoParquet, it's 532 megabytes. So it's less than half the size, and that's based on that column-based kind of file compression. So stepping back a little bit, what this really means is that if you have large data sets, so let's say you're doing kind of an exploratory data analysis of the whole country, of building footprints, where they interact with counties or parcels or whatever, you can store vector data so much more efficiently, and you can access that data more efficiently. So I know that, with COVID and kind of the working from home situation, no one has ever had issues accessing data on a VPN, right? So if you're doing kind of like a one-off exploratory analysis, mess around with the GeoParquet, and you can really see the difference. I've done some analyses in Arc Pro using geodatabases on my C drive, and that takes a couple minutes to execute on a few million records. If I do the same in a GeoParquet, it's a matter of seconds. So, you can really build in efficiencies in your kind of processing pipeline. And in addition, you can really take advantage of a lot of the really cool aspects of Pandas and GeoPandas too. So how can you leverage Python and Parquet files? So I kind of hinted at doing exploratory data analysis. I really like to prototype my analyses out in Python just because it's a lot easier to kind of write it in Python. So if I ever forget, I can go back and reuse it, or if I have to drop a different data vintage in, it's pretty easy just to change the file path. If you're just storing files, wanting to archive them, you can just store them in GeoParquet. Or if you're moving towards like a cloud-based data processing pipeline, GeoParquet is awesome in data lakes or data warehousing online, like Snowflake, I think, and AWS is used. But really, I have come to really like GeoParquets, and that's why I wanted to give this talk. It's something cool to play around with, and it's a lot different from the typical kind of geodatabase and shapefile, but allows you to really go outside of your comfort zone and do a lot of really interesting things. So at my job at the Broadband Authority, I've prototyped a couple analyses, 35 million records of tabular data that we process twice a month, every month for the last year straight. So I use pandas to really crunch those numbers and even interact with spatial data. And it's a couple minutes, like every 2 weeks that this runs. I think from downloading the raw like zip files to processing time completion is 12 minutes. So that's a couple gigabytes worth of data that's compressed and do analyses on. So that is kind of the overall part of my talk. I know I flew through that, but any questions? I know that was a lot. Yes.
Hi. And maybe I missed this because I came in a little bit late, but any kind of way to work with these files in an Esri software environment? You know, if you do an analysis separately using the Parquet files with GeoPandas, and then you want to visualize something in Pro or in somewhere else, is that possible?
I believe Esri does have some compatibility online, and maybe that's more with its developer API. I personally convert these then to a different file format, but to do the analysis up until that final product, it's a lot quicker to make a new file in a GeoParquet format and do all the analysis. I feel like the time savings personally has been worth it for me. But no, you can then go from GeoPandas and export it to like a Geo package and pull that into Pro or Shapefile or whatever you want. But I believe there is some integration with the developer API. And one other kind of quick comment that I'd throw in is that, Pandas and GeoPandas is, if you have ever seen a Jupyter notebook or kind of going through how Arc Pro is, especially with like ArcPy, it's a little bit similar in how you can kind of do that line by line analysis. And pardon for not having examples of that, but you can type in a simple line. So if you want to do a spatial join of building footprints onto a county, it's literally declaring a variable and then just putting that same syntax in. But the nice part about GeoPandas compared to like an ArcPy is it does all of this in memory, in your RAM. So if you have 32 gigabytes of RAM on your computer, that's where it stores all of the intermediate files, and you're not saving out a bunch of scratch files on your hard drive. So throughout the whole kind of processing pipeline, there's a lot of efficiencies built in because you're not saving these one-off files as you go. But question?
Is there a different dictionary as the standard Pandas stuff that's used for this?
So you can interoperably use Pandas and GeoPandas, and that's where it gets a little bit funky. So in Pandas, if you want to join two tables, it's pandas.merge is the command. In GeoPandas, you'll have to do that to join tables. So you kind of use them interoperably, and like if I am writing a new script or analysis, I declare both of them at the start of that script. So I bring in both Pandas and GeoPandas because there is a lot of mix and match. GeoPandas is relatively new. It's still being kind of processed and brought up to, I think, a version 1.0. So there is a lot of overlap between the two packages. Yep.
Any other questions?
Yeah. Ask as many questions as you want.
Okay. You mentioned Jupyter Notebooks briefly there. Is that your primary developing environment when using GeoPandas?
Use the Notebooks extension inside of VS Code.
Okay.
So I write everything primarily in VS Code. I kind of prototype things out in Notebooks, but then I'll save it out as just a plain .py file. Gotcha. So
I did not even realize there was a Notebooks extension to VS Code. I'm going to have to look that up when I go home.
it's glorious.
So full disclosure, I work very closely with Kyle every day, and we have this discussion a lot, but I think it could be beneficial. I use PostGIS for my type of analysis. I wonder if you could go over what you see as why this workflow may be more beneficial compared to something like PostGIS.
Sure. So as Greg had mentioned, he does a lot of work in SQL databases, and as we have mature data sets, a lot is stored as a SQL backend, and that's great if you have like a kind of a fixed schema, or you know that data will stay relatively the same. I think the benefit here is, have you ever just pulled in a shapefile to look at it, or pulled in a shapefile because you're doing something once and will never touch it for 6 months? I think that's really where you'll see a lot of these gains, especially if you're doing analyses at scale. I know some of the folks here work for the state, so like statewide road layers that are pretty big to begin with, and you have to calculate the linear length of all of them in feet. Something like that, you'll see a lot of these efficiency gains in the compression of the GeoParquet. And when you're done with the GeoParquet and you're like, well, I think this is mature, or I never want to see this again, you can either just kind of click delete, or you can even export it and then put it into a SQL database. There's that interoperability that GeoPandas gives you. So you can actually export that directly into a database table. So it's kind of nice to have some interconnectivity between kind of like more robust databases versus a file-based storage solution.
All right, one more.
Ask as many as you want.
So when you're doing this stuff in VS Code,
Mhm.
or when you're running some sort of GeoQuery on whatever you're doing, is this something that you can see the result of it immediately? Like you can pull up a map frame within VS Code and view it, or is this something like I know a few years ago it was you pulled up Arc
Mhm.
after doing this stuff and then you viewed it. Is it still that way for this particular circumstance, or is this something that you can pull up a window internally to the application that you're using?
So, both. It's whatever you want it to be. So the beauty of kind of using GeoPandas and Pandas is, if you want to do a field calculation in Pandas, you can then type like dataframe.head, and then you'll see the top 5 results of your data frame. Or if you wanted to plot it, there's also other Python packages that you can use to plot and visualize your data. Or if you wanted to make a scatter plot of the data and not even look at it spatially, you can do that too. So you can layer all of that whole Python ecosystem together to really build like a robust output of whatever you want. So down here, pandas-Bokeh. Bokeh is like a very specific Python package. Disclosure, I have not used it, but you can use that to output like plots and stuff like that. And I think Shapely allows you to plot, like if you have a state of Pennsylvania layer, you can output that kind of on a graph to see where it lies, like on a Cartesian plane. So you can layer all of these elements together to really visualize both tabular and spatially what your outputs are. And if you wanted to, you can then just export it to like an actual file and drag it into QGIS. Allows you to natively read GeoParquets, but you could export it to a shapefile and drag it into Arc if you wanted to. Yeah, not a problem.
Last call for questions.
I appreciate the questions. I know I went fast, but I'll stick around for a couple minutes afterwards if you have any additional questions, concerns, or anything like that. But thanks for taking the time.
Thank you, Kyle.
Yep.
So we're now on a lunch break until 1 p.m. Sessions kick back at 1 p.m. up here and also on the 11th floor. I think you can take the elevator down to the first floor. If not, someone can get you in the elevator on 11. All right, so you take the elevator down to 1, get some lunch, get back here by 1.